All right, so for the next part, we are on lesson 2.7, part 2. Take a look at the problem of the day and answer your question. So we're going to take a look at graphing. We talked about the characteristics of what happens with an absolute value graph, right? And how to write the equation from the graph. Well, now we're going to do the opposite, actually write or draw the graph. So here's a trend here that we keep seeing. We want to talk about the slope and the vertex. So I'm just going to use the letter V for this. The vertex should be what? 1, 3, or H, comma K, right? X, Y. And my A, or my slope, is the number in front. It's going to be 1, right? So now to show you how we graph this. All right, the vertex is easy. So 1, 1, 2, 3 is here. Remember, the X or the H is always the opposite. It's like we're setting that equal to 0. And my slope is 1, or 1 over 1. So how you do a slope of a line is the same as an absolute value graph. We go up 1, right 1. And I'm going to do it one more time. Up 1, right 1. Now, how's this different? We know the absolute value graph is V. So I'm going to connect my points here. And now what we have to do is do the opposite. What I like to do, it's like a mirror image of it. I go back to the vertex. This time I go up 1, left 1. Up 1, left 1. So to get the other half of the V graph, you go back to the vertex and go in the left direction. That's my graph for it. So let's do another one. My vertex is -3, comma, -2. My slope this time is 1/4. All right, so plot the point -3, -2, which is here. That's my vertex. And now my slope is 1/4. So how do we move 1/4? Up 1, right 1, 2, 3, 4. Could do it again. Up 1, right 1, 2, 3, 4. And if I could draw a straight line here, almost. Okay, there we go. That's okay, right? Sorry about that. It's hard to draw with my mouse here on my laptop. You get the idea. And then if we go back to the original one, go up 1, right, left 1, 2, 3, 4, and we could do it again. You see we go off the grid, so that's okay. You could just plot the point and connect them. And do you remember if we go back from yesterday, we said if the absolute value of the A, which absolute value of 1/4 is what? 1/4? It's a less than 1. So look how wide 1/4 is compared to a slope of 1 or an A of 1. Here's the standard we have been using with the slope. Here is 1/4. So here's 2 more practice problems. What I'd like you to do is actually pause the video and try them yourself first to see if you could get some practice with them, because it's pretty much the same thing over again. Once again, we want the vertex, the slope. Vertex is 5, -1. The slope is 1/3. So 5, 1, 2, 3, 4, 5, -1 is here. Slope is 1/3, up 1, right 3. And this time I'm not going to do a third point because you see it's going to go off the grid. So I'll just do one of each. Up 1, left 1, 2, 3. Make sure you have a V graph. Make sure, a common mistake I see a lot of times is people just graph a regular line, which I don't really understand how it's an absolute value graph, but I've seen it before. So make sure it's a V, and you do sort of like the mirror image points on the left-hand side. All right, for the last one here, my vertex is 1, 3, H, K. My A is -2, or -2 over 1. So I go 1/3, or excuse me, 1, 3 is my vertex. Right 1, up 1, 2, 3. There's the vertex 1, 3. And my slope is negative this time. So we know negative means it's going to open down, right? We saw that on that little GeoGebra slider. We go down 2, right 1. And just because I have enough room, a lot of times, like I said, I'll do 3 points unless it goes off the grid. You can see here that it's a -2, so it opens down, and it's actually steeper. Do you see how absolute value -2 is 2? So it's narrower than the last one. This one's wider. So that's it for the lesson. Make sure you do the problems, problem of the day, and the 6 problems in the packet.